Okay, in this video I'm going to walk you through making a test bench, and we're also going to talk about how to submit an answer in Canvas to verify um, your half adder, full adder, and test bench code within Canvas. All right, so let's get started. All right, so we're going to do a full adder test bench, and so that's a module, right? Full adder test bench. And remember, test benches don't have inputs and outputs. All right, so we'll end that module and then get started with our test bench. All right, so one of the things we need to control are the inputs. And we know that we're looking at inputs, the test register for X, the test register for Y, the test register for the carry N. Okay, I'm going to call them slightly different variables because they're the test vectors, all right? So we're putting in test variables, and so I'm putting a T subscript on these. All right, and so those are the inputs. All right, and then we have some wires for S and C that we can look at. All right, so from there, we just need to instantiate our test bench. I'm sorry, our full adder. Right, so full adder. Right, so look, I have .x as an input, so I'm controlling that input with the xt. .y controlled with yt. For the full adder, I look over here, the input is z, so .z is what I'm connecting to cin test. All right, and then my output .s is s, and my output for the carry, I'm also calling carry. All right, so that's instantiating the full adder. And so we can start with an initial block. All right, and so this is going to have more than one line. So you want to have a begin and an end. All right, and so what I want to do here is I want to turn on the monitor so I can monitor the variables. All right, and I'm going to want you to get the syntax on this exactly right, because what I'm going to do is ask you to cut and paste the output log into Canvas to verify that you've done the full adder, half adder, and test bench properly. All right, so that's our output for the quiz. All right, so we start with a double quote, and then I'm going to put xt equal, no spaces, %b, no space, then a space, yt equal, %b, no spaces, then a space, right, c int equal, %b, then a space. All right, and we're going to also look at the carry first. That's how we did our truth table in class. C equals %b, and then we'll look at the sum bit. All right, then we close that quote. So, you know, we have xt equal %b, no spaces, yt equal %b, no spaces, and so forth, all the way for xt, yt, cint, c, and s. All right. Then we tell it, this is C-like, right? So we tell it the variables that we want to monitor and print to the screen. So it's xt, yt, cint, t, c, and s. All right, so that, we've set up our monitor command. All right. The other thing I'm noticing is, I'm not sure if this happened when I edited. I thought I ended that module before, but I'm not seeing the end module to match the module. All right, so you know, I've been burned on these before, so I'm trying to match begins and ends and close different sections of code. All right. Again, with since it's a test bench, there's no inputs, there's no outputs. We use registers to control the inputs, and we put the outputs out to wires. Okay, so next I want to generate the input conditions, and you could just type the 7 input conditions out, but I'm going to use a loop. And because I'm using a loop, I need a loop counter, so I defined integer I. Okay, so I starts at 0, and I hit a semicolon. And then as long as I is less than or equal to 7, we're good. So we're going to stop at the 7 input conditions, the 8 min terms that are generated for the full adder truth table. And then I put the increment I equals I plus 1. Close parentheses. There's no semicolon there. We're beginning and ending the for loop, all right? And so from here, I can use concatenation to generate the input vector. So xt, yt, cnt, curly braces, concatenate those together and assign the bit values of integer I into xt, yt, and cint. All right, then we're also putting in a time delay after every input condition. So put the, pound 1, pound 5, we need some time delay showing up between input conditions. All right, and so that should generate that. And then finally, I want to end the simulation, and I make sure I have semicolons in the right places, and this is starting to look good. All right, so at this point, what I want to do is try to slide the screen a little bit. Maybe I can move this up. All right, so when I hit run, it generates the truth table that we talked about in class for the full adder. So you can check that. 0 plus 0 plus 0. The sum is 0 and the carry out is 0. 0 plus 0 plus 1. The sum is 1 and the carry out is 0. So you can go through all these combinations. Here's 1, 0 plus 1 plus 1. The sum is 0 and the carry out is 1. And finally down here, the last one to check, you can check all of these. But 1 plus 1 plus 1 is 1. The sum bit, carry out 1. So this looks like the proper truth table. So what I'm going to want you to do in Canvas, and this is important, is I want you to select exactly this part. Not any more, not any less. And Control-C or copy that and paste this output from the test bench into your Canvas quiz. All right, so that's how I'm going to check your work. All right, so very important on that. Once again, copy and paste that, select it into the appropriate spot, or paste it into the appropriate spot on the Canvas quiz. All right, so there we have it. The test bench setup for the full adder. We construct the full adder from 2 half adders. And you're supposed to take away from this that we are doing a hierarchy of design. So we have different modules and we connect those together. All right, from there, we're going to start connecting the full adders together to make a bigger adder that can add, in the case of this lab, we're going to add 2 4-bit numbers, and we're going to also be able to subtract those 2 numbers.